Hi, my name is Mr. Barr. This is the Math 8 Goal Number 8 Functions Practice Test, version 1.1. This table shows the linear relationship between the number of songs downloaded and the total cost. So I want to find the rate of change. That's a fancy word for slope. So these are my x's, these are my y's, these are actually my runs, these are my risers. So from 3 to 6, how did it change? It went up by 3. From 267 to 537, how did it change? It went up by 2.64, $2.64. I do rise over run, and that gave me 89 cents. This table represents a linear function. Create an equation for it. Okay. Well, I'm going to need my slope. It's asking me to create a slope-intercept equation, y equals mx plus b. Let's find my slope. So I found my change right here. That's going up by 3. I found my change over here. That's going up by 1. So rise over run is 1/3. There's my slope. In my y-intercept occurs when x is 0. So right here, where's x 0? Well, x equals 0 is in between these two numbers. It's halfway in between those two. So what's halfway in between 0 and 2? 1. So there's my y-intercept, and now I put it together. Y equals 1/3 x plus 1. An incomplete table is shown. Fill in the empty cells in such a way that the table does not represent a function. What I'm looking for, I did it like this. I did 8 is grabbing 16, and 8 is grabbing a 17. So right there, I doubled up on my 8s. You could have doubled up on your 4s or your 12s, but I doubled up on the 8s. And my reasoning is this. Since 8 takes 16 and 8 takes 17, it is not a function. Each x can pair with only one y. So whenever I see this happening, it's not a function. Explain how the vertical line test works. If a vertical line touches a graph in more than one place, then it is not a function. Here's an example using a circle. If I draw a vertical line through a circle, it touches a circle in 2 places. Therefore, it is not a function. On the diagram below, draw arrows from the input values to the output values so that the relationship represents a function. Use as many arrows as you wish and as many input and output values as you wish. So I just used this. I went boom, boom. -2 is paired with -6. 9 is paired with 10. That's a function. If I'd done something like this and had this guy grab 2, then it's not a function. Explain my reasoning. Each x input gets only one y, or output. Maria is going on a hike. The graph shows her distance from home over a period of time. Explain what each little piece means. Well, A to B means she's getting away from home, going away from home, going away from home. Right here, the distance isn't changing. So right here, she's just kind of sitting around, going away from home, going away from home, going away from home, sitting around, coming home, coming home, coming home, coming home, coming home, back at home. That's what it means. So B to C, she stopped moving. D to E, stopped moving. E to F, walking back to her house. Determine if each function is linear or nonlinear. What I did is I plotted these on a piece of graph paper. Let's see. This first one, it kind of looks like it is linear, but that guy's, it doesn't work. That's not a straight line. They're crooked. This one is linear. See that? That's linear. This guy right here, let's see. Is that linear? Yep, that's linear. That's lining up. And this one here, that's not linear at all. Actually, that's not even a function. Determine if each function is linear. Let's just put a note here. This is nonlinear and not even a function. How do I know it's not a function? Well, vertical line test it. Look, right there. Vertical line touches it in 2 points. It's not a function. Number 10, the table and equation. The table and the equation below represent 2 different linear functions. So here's a linear function and here's a linear function. They're lines. Y equals mx plus b. Which function has the greater rate of change? Well, right here, I need to find the linear function, or the slope-intercept equation. So let's find the slope. From -4 to -2, that's going up by 2. And -3 to 0 is going up by 3. So my slope is right here. Then I come down here looking for my 0. There's my 0. There's my y-intercept. So I've got that. Let's put it together. Y equals 3/2 x plus 3. So here's my function for this guy, my linear function for this guy. Here's this linear function. Let's compare them. So we have 5/6 versus 3/2. Who's bigger? This guy's bigger. That guy's the bigger one, so which one has the greater rate of change? This one has the greater rate of change. It's got a bigger rate of change than that one. Bertram and Patrick are walking to school. The distance on the graph is each student's distance from home. Bertram walked straight to school without stopping. Patrick started to walk to school, stopped to tie his shoe, and then continued the rest of the way. So here's Bertram walking to school, walking to school, walking to school, walking to school. Here's Patrick walking, 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 stopping, 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 walking, walking, walking. Cool. Thanks for watching. Bye.